Language design is the art of writing a high-quality language. To define what high quality means, you first have to define the purpose of the language. First, I want to give you an example approach on how to design a modeling language, so a software language that is used to model a system or software. Before you even start thinking about designing a new modeling language, you should clarify whether you can reuse an already existing modeling language. If not, there are some basic steps to take in order to ensure that your designed modeling language fulfills all its demands. In our example, we want to develop a language for finite automata. In a first step, you should write down several examples that capture the essential information to be conveyed by models of your domain-specific language. In case of the automata language, this is, for example, every automata has states and transitions. Next, identify concepts of your domain-specific language and its structure. Afterwards, when you already have the basic structure, take a closer look at possible border cases. For automata, this might be the case for multiple finite states or non-determinism. Also, ask yourself what the user of your language might like to be able to do with it, like for example giving states and transitions custom names. Of course, many other use cases are possible in this step. An example automaton that you designed in your language using a concrete syntax might help you out in this step. Now precisely define the abstract syntax, so the language concepts of the DSL. For the automaton example, this includes non-terminals like states or transitions, identifiers like name, and semantically relevant keywords, for example, to mark the initial state. In a fifth step, you want to extend the abstract syntax with so-called syntactic sugar. This is non-essential syntax designed to make the language easier to read and use. In the example automaton language, you might want to introduce from and to for transitions. Next, derive a data structure that represents the abstract syntax. Class diagrams are very helpful to understand this representation. Finally, derive a parser to translate models of the language into the abstract syntax. Therefore, you want to implement useful context conditions. Through context conditions, well-formedness of models can be checked. In our case, an example context condition would be that every automaton has to have exactly one initial state. Let's consider the term quality again. As with most things today, there are a lot of different definitions for quality. However, one thing is very important. Quality is always relative to a set of requirements. In software engineering, quality of a language, or more specific, a domain-specific language, can refer to two different things. First, the quality of the language definition, or second, the quality of the language infrastructure, like parser, code generator, and so on. However, talking about quality in software engineering can also mean the quality of the artifacts of the language, so its models. Also, it can refer to the generated product.